Okay, we're going to take a look at the median and medians and altitudes. Median, it is a segment connecting a vertex to the midpoint of the opposite side. If you draw all three medians into a triangle, they will intersect at the centroid. It is the point where the three medians of a triangle intersect. Let me go back up, kind of draw a picture of a median. So a median starts at a vertex and it goes to the midpoint of the opposite side. So I have to go to this opposite side, find its midpoint. So it has to be right in the middle of those two and connect them. That is a median. And so you can see in this picture here, they've drawn all three medians in, and they all intersect at one common point, and that point is called the centroid. So here where it says concurrency of medians of a triangle, it turns out that that point is located, if you start at not the vertex, but if you start at the midpoint and you start your way across the median, the centroid is a third of the way across. The centroid is 1/3 of the way. This is not really a textbook definition, kind of my own wording. It's 1/3 of the way across the median when you start at the midpoint. So then in parentheses, I would say 2/3 if you start from the other side. If you start from the vertex. So 2/3 and 1/3. So if we come down now to this picture, notice they're saying from S to Q is 8. Well, that's starting at the vertex. That's the long way. So if we start at W into Q, that would only be 1/3. Well, if we compare 1/3 to 2/3, if you think of 1/3 and 2/3, 2/3 is 1/3 plus another 1/3. It's two of them. It's twice as long. So if this is 8, you can cut 8 in half and you get 4. That's what that has to be. And if you add the whole thing together, 4 plus 8, the whole thing is 12. What's 1/3 of 12? 4 is. So 2/3 is 8. So they want us to find QW and SW. So for QW, we had to just cut the 8 in half, so we got 4. SW is all the way across. 8 plus 4 is 12. So altitude is also known as a height. That's going to be our other one here. So it's a segment from a vertex and perpendicular to the other side, to the opposite side of the triangle. So you can see that here. So we start here at Q, go to the opposite side, perpendicular, there you go. Every once in a while the altitude is outside the triangle, because if I start at Q, I can't come down perpendicular to that segment and hit it, so sometimes I have to extend the side so it's perpendicular to the side extended. You can see that there. The orthocenter is the point where the three altitudes of a triangle intersect. Now, we don't really have anything too special to say about an orthocenter. It's not like it's halfway. It's not. It doesn't create any bisecting or anything like that. But you can see in this picture that if it's an acute triangle, the orthocenter happens to be inside the triangle. When it's a right triangle, the orthocenter, let's see, happens to be on the triangle. And when it's an obtuse triangle, the orthocenter happens to be outside, because here was the triangle itself. So we had some heights that were outside the triangle, so they all intersect out there. So it can be inside, it can be on, or it can be outside. Because of that, we can now go to our concurrency sheet, which if you're in class with the sub, you haven't received it. You'll receive it tomorrow. If you're watching this video later, maybe you have a concurrency term sheet already, and you could go ahead and add those things on. Otherwise, we'll do that in class later. All right, that's the end of the notes for 5.4. The assignment is on the back, and there is a Canvas quiz where you can and should and need to submit all of your answers.